guys, welcome back. Today we are going to be working on another GMAT problem, and this problem happens to be number 117 in my GMAT book, which I will leave a link for in the description. And this particular question has to do with computation with radical expressions. So the question says, if n is positive, which of the following is equal to 1 over the square root of n plus 1 minus the square root of n? So I didn't include the answer choices in this question, but that's okay because we are going to go through it anyway and get the answer at the end. So the first thing you want to do to this is you want to do something that's called rationalizing the denominator. So this is called a rational expression because it has a radical, or it has that square root sign. So one way to get rid of that is to multiply by the same expression except for have a plus in the middle of the two terms, and I'll show you why that works. So if we have 1 over the square root of n plus 1 minus the square root of n, and we multiply this by the square root of n plus 1 plus the square root of n over the square root of n plus 1 plus the square root of n, we get, so I'm going to multiply the top first, and I'm going to get the square root of n plus 1 plus the square root of n. Now let's focus on the denominator. So when I multiply these first terms here, I'm going to go ahead and get an n plus 1. When I multiply these outer and inner terms, they're going to cancel out, and that's why this method is so effective. So I'm going to show you in blue what would happen. So when I multiply this by this, I'm going to get the square root of n times the square root of n plus 1. But then when I multiply these terms here, I'm going to get minus the square root of n times n plus 1. So we don't even have to worry about what these actually multiply out to be. The important thing is that they're going to cancel out. So we're not even going to write those. So we're just going to go ahead and forget about all of this. So going back to our foiling, we already multiplied our first terms, our outside and inside terms canceled. Now we're going to multiply our last term. So now we're going to be doing this here. So now we have a minus square root n times a positive square root n, and that is just going to give us a minus n. Because remember, anytime you multiply the square root of something times that same square root, you just get the number on the inside. So what I mean by that is if you multiply the square root of 8 times the square root of 8, you just get 8. Because this here, this is just the square root of 64, which is 8. So going back to what we were doing, now looking at the denominator, we notice that we have this n minus n. So when we combine like terms, those are going to cancel out again. And now we are going to be left with this square root of n plus 1 plus the square root of n over 1. And anytime something's over 1, we don't have to actually write that part. So our final answer is going to be the square root of n plus 1 plus the square root of n. So again, this question was an algebra question, and its subcategory was computation with radical expressions. So if you had any trouble with this, I would recommend going back and reviewing radical expressions, and maybe just algebra in general if any of the fractions were a little confusing or anything like that. So I hope this video was helpful. If it was, I would appreciate it if you like it and also subscribe to my channel. And I hope you all have a great time studying and a good weekend. Alright, thanks for watching.